7.2 Hypothesis Tests for the Mean using Z. We saw a little bit in 7.1 about how to set up a hypothesis test and how we can decide and interpret that decision to finish off a hypothesis test. What we want to look at now is how to make that decision, and we're going to base it on something called a p-value or a probability value. The idea basically is we want to gather our evidence from the sample and see if it's enough to support or maybe reject the claim that we're testing. The p number represents the size of the shaded area. So we might see a homework question, something like this example, where we want to match the p-values with the graphs. The idea is the bigger the p-value, the more shading we'll see. So graph A here definitely has a larger portion shaded than graph B. That means it would go with the larger p-value. So a p-value of 0.2802 would match graph A, and the 0.688 would match graph B. So we'll be using the calculator to find these p-values, and what we want to do is we want to compare it with the value of alpha, the chance of making an error. If p is less than or equal to alpha, we'll reject HO. And if p is greater than alpha, we fail to reject HO. So we're just going to compare these two values, and that'll help us know which decision to make. You'll see some homework problems where we are given a p-value and asked to see what the decision would be at various levels of alpha. If p is 0.0691, would that be less than or greater than 0.01? So we want to compare our p number, 0.0691, with our alpha number, 0.01. And we see 0.6 is definitely bigger than 0.1. Since the p number is greater than the alpha number, the decision here would be fail to reject HO. Remember, our decision is always about the null hypothesis, which may or may not be the claim. That's why there's always an interpretation to finish off the hypothesis test. So part A would be fail to reject. Maybe you'd push pause on the video and see what the decision would be for part B and part C. The p-value of 0.0691 compared to the alpha value of 0.05. 0.06 is still bigger than 0.05, so this one would also be fail to reject the null hypothesis. And for part C, again, we have a p-value of 0.0691 that we want to compare with an alpha value this time of 0.10. 0.06 is less than 0.10, so the decision for part C would be reject. So that's kind of the last piece of the puzzle. When we combine this with what we saw in 7.1, we're ready now to perform a full hypothesis test. To find the p-value on the calculator, we'll go back to the stat menu, over to the tests menu, and select option number 1, z-test. We'll want to make sure stats is selected, and then we'll enter in all of our values and go down to hit calculate. So for this first problem, we're back to the example where the USA Today report states that an average age of commercial jets is 14 years. So that sounds like a very general statement. They're talking about the average age of all jets, the whole population. A certain airline claims that the average age of their jets is less than the national average. So they're claiming that their jets are newer. The airline randomly selects 36 jets and finds the average age of those 36 to be 11.8 years. Throughout the test, we're basically trying to determine if 11.8 for that sample is small enough compared to 14 to allow us to support their claim or not. We're also told that sigma is 2.7, and the level of significance we want to use is alpha equals 0.01. So some of the information we'll need to gather to put in our calculator later on is the sigma value, which it says right here is 2.7. X bar, which is the average age of the sample. Those 36 jets had an average age of 11.8. And we also need the size of the sample, which was 36. So let's see if we can support the airline's claim. This airline claims the average age of their jets is less than the national average. We're definitely talking about an average, so mu will be our symbol. To represent is less than, we want our inequality symbol is less than. And we know that has to go next to the alternative because it does not contain a statement of equality. So this airline claims their average is less than the national average, which we saw up above there was 14. And that's the claim we're wanting to test. The opposite of that then will be our null hypothesis, so that we know between the two every possible value of mu is included. And just to kind of emphasize with a picture, remember from the previous section that less than means we're talking about a left tail test. And we want to find the area of that left tail test with our calculator, the p-value. So like it says up at the top, we're going to go to the stats button, over to the tests menu, option number 1, z-test. Make sure stats is selected, since we already have the summary statistics, not the actual data values for the sample. And put everything in. Next to mu, we want to put the national average, or in other words, the number that's included in our claim. That would be 14 here. And then we want the sigma, x bar, and n typed in, 2.7, 11.8, 36. And lastly, let the calculator know which alternative hypothesis you're using. Is it the not equal, the less than, or the greater than? So this one, of course, is the less than. Then we'll go down and calculate. And several values are given here. The one we're really looking for right now is the p-value, which apparently is a tiny number. It looks like this is scientific notation. So the decimal is not really here. It's actually 7 places to the left, which will make 6 zeros after our decimal point. 1, 2, 3, 4, 5, 6, and then a 5. So let's compare that with the alpha they gave us in the problem, 0, 1. And that tiny number is definitely smaller. We said if p is less than alpha, we should reject the null hypothesis. And remember, our interpretation is based partly on where the claim is. The claim this time is next to the alternative hypothesis. So by rejecting the null hypothesis, we're going to go with the other one, the alternative, which means we're going to end up supporting our claim. So it looks like in this case there is sufficient evidence to support the claim that the average age of jets at this airline is less than the national average. Sometimes instead of the word sufficient, you'll see the word enough. Either one of those will be just fine. And notice what we're finding. Based on this sample, the mean of 11.8 apparently is significantly lower than 14. It's enough lower that we believe this airline's jets are younger than the national average. These hypothesis tests can be quite overwhelming at first because we're bringing together a lot of different ideas we've been working on. So don't be surprised if it's a little bit much, but as you work on them, remember that we have a lot of different details to keep track of. All of those different details are outlined a bit on the next page, along with sort of a general plan. So if we're going to use Z, one thing we need to do is make sure we have the population standard deviation, sigma. And once we know that, we can go ahead and set up our hypotheses, keeping in mind which symbols need to be a part of each hypothesis. Then we'll use the calculator to find that p-value. And we'll use that p-value to decide if we're going to reject or not the null hypothesis. And then we'll interpret that decision based on whether the null or the alternative represents the claim. That'll help us know exactly what wording, what lingo to use. So depending how confident you feel, you might want to push pause, read along the next example, maybe fill in as much as you can, and then check back in whenever you're ready. This time we're looking at a sprinkler system that's designed to put out fires. The manufacturer claims that the average activating temperature of their sprinklers is at least 135 degrees. To test that claim, we get a random sample of 32 systems and find the mean activation temperature to be 133 degrees. We have the population standard deviation. We have a level of significance. And we're asked to see if we can reject the manufacturer's claim or not. So let's see, sigma, they told us was 3.3. The evidence they collected from their sample found an average of 133 degrees. The sample included 32 systems. The manufacturer claims that their average activating temperature is at least 135 degrees. For at least, we want to use greater than or equal to. We are still talking about an average, so mu is what we'll see. Then the opposite would be less than. And looks like we're talking about another left tail test. So to find that p-value, let's go back to stat, over to tests, and choose z-test. Mu is the number from the claim, so that's 135. Standard deviation they gave us was 3.3. X bar 133. Sample size 32. This alternative hypothesis again is a less than. And we calculate, looks like p is another tiny small number. E to the -4 means we're going to move that decimal place 4 spots to the left, which makes 3 zeros and then a 3. The alpha in this problem is 0.10. So that 0, 0 number is definitely less than or smaller than the alpha number. When p is less than alpha, we are to reject the null hypothesis. If we reject the null hypothesis, then it turns out we are rejecting the claim. So we'll say that there is enough or sufficient evidence to reject the claim that the average activating temperature is at least 135 degrees. If you look back into the numbers, it probably will kind of make sense. If we're trying to prove it's 135 or higher, but our evidence gives us an average of 133, that's not very convincing, is it? By the way, on the calculator screen, we also have been given a z-value. Once in a while on the homework, they'll also ask you for that z-value, which is letting us know where this shading cuts off. So if I rounded that off, that would be -3.43. There's one more example of a hypothesis test on the next page. This would definitely be a good time to push pause, try working as much of that problem as you can on your own, and then checking back in to see how you did. So our claim this time is that the average is 6.3. Alternative would be not equal. That makes it a two-tail test. On the calculator, we can get our p-value by putting in the 6.3, the 2.5, and so forth. So 0.386, which turns out to be less than alpha, so we reject HO. If we're rejecting the null hypothesis, we're also rejecting the claim. So we have enough evidence to reject the claim. Notice our z-scores on here. This would be a positive 2.07 and a negative, just in case they ask that on the homework. And one other thing you might look at, back when we were on this z-test, down at the bottom we've been hitting calculate, but there's also an option to draw, and you'll end up seeing a picture just like we have on the homework here with the z-score and the p-value.